Good morning, everyone. Let's see if folks are letting. Okay. Good morning, everyone. Thanks so much for joining us this morning. My name is Tessa Peters, and I'm the Commercialization Manager at the Land Institute. And I'm going to introduce Jake Youngers. Jake's an assistant professor in the Department of Agronomy and Plant Genetics at the University of Minnesota. As an agroecologist, Jake's research goal is to improve and develop new cropping systems that provide high-value agricultural products, enhance farmer profitability, improve water quality, and reduce greenhouse gas emissions. He conducts cropping system trials that include small grains, oilseeds, perennial forages, and novel perennial grain crops at the university on research stations and on farm. And with that, we'll let Jake get started. Thanks.
Morning, everyone. I'm going to share my screen here. Today, I'm going to be talking about how intermediate wheatgrass can be used as a dual-use crop, a crop that growers can earn revenue from managing as both a grain crop and either a forage or a grazing crop. So I'm going to go over two different studies or projects. The first is an experiment that we conducted looking at the dual use potential of intermediate wheatgrass as a grain and forage crop. So when I say forage crop, I mean simulating a forage harvest mechanically. So I'm going to review the effects of mechanical harvest and also row spacing on grain yields. And then I'm going to present some results on the economic potential of this system, the system that's used as both a forage and a grain crop. Then we're going to introduce animals to the picture here and talk about some preliminary results from a real grazing trial. And there are two experiments that we conducted in this grazing trial. One was a mob grazing experiment and one was a fall strip grazing. And I'll explain the details about those when I get there. So we'll start off by talking about what has become to be known as the Cullman study. Essentially what I'm doing here is presenting results from Minnesota's site of the Cullman study. And this work was just published, and it's really Mitch Hunter's work. This is data that he took and analyzed, and this is really most of everything that I'm going to be presenting comes from his analysis. So he'll have, if there's any real detailed in-depth questions, he might be the better one to answer, but I'll do my best. So these are two papers, companion papers that came out in Agronomy Journal, I think actually just in this month's issue. So lots of really good information here, way more information in these two papers that I'm going to present to you today and give you kind of a higher level overview, very specific to the effects of grazing and defoliation on grain yield. Okay, so let's step back and review how an intermediate wheatgrass system can be managed as a dual use system. So if we're looking at just a grain production system, the plants grow in the spring, grow vegetatively for a period of time. Then stems begin to elongate, they go through anthesis, grain's ready to harvest in August. And then after the grain is harvested, typically the straw is removed. And then the intermediate wheatgrass continues to grow just purely vegetatively here in North America for the rest of the fall and up into the winter. And then it goes dormant throughout the winter, and the cycle begins again in the spring. So there's an opportunity to either harvest forage or to graze in the spring, in that period of time before, between spring regrowth and stem elongation. So we'll talk about what the value of that potential value of that forage might be, and then also what the effects of a spring graze would have on a grain harvest. There's also an opportunity to graze the fall regrowth. So again, we'll look at those same parameters, economic value of a fall grazing or mechanical harvest system. And we can really push the system by doing 2 different grazings or defoliation events in combination with our grain harvest in a single season. In this first experiment, we've also manipulated row spacing. So you'll see the results presented with row spacing integrated into the figures and in with the data. So with 3 row spacing treatments, 15, 30, and 61 centimeters apart. And this picture, you can kind of see a little bit of everything. Here on the right-hand side, this is a different experiment, so that's not part of anything, but you can see that these lighter green plots were recently defoliated. So this is regrowth after a defoliation event. You can see the darker green areas were plots that were not defoliated, and you can see the different row spacings here in the foreground, the 61 centimeter. This is probably the 15, and back here is probably the 30. So just give you a glimpse of what the experiment looked like after it was initiated. And this ran from 2015 to 2019. So let's start with grain yield and the effects of defoliation on grain yields, effects of defoliation and row spacing. So I'm going to show you a series of panels and data, and on the y-axis is grain yield in kilograms per hectare. And then the different colored bars represent the means after different defoliation events. So in the first year of this study, we only had control plots and spring grazing because we didn't yet got to the fall grazing events. Grain yields harvested in August, fall grazing was in October. So what we can see here from this first year is that in the wider row spacings, we actually had an increase in grain yield with following the spring grazing. That really only prevailed in the wider row spacings. And that's an interesting finding because it presents a win-win situation for a grower. Grazing provides an additional source of revenue, but also increases the primary revenue stream. So the next question is, well, this is a perennial crop. Does that same pattern hold through time? So then we can move on to the 2016, the second year data. What we see here is that, first of all, there was an overall reduction in grain yields. And this is probably a trend you're gonna see in a lot of intermediate wheatgrass data coming from upper Midwest. In this case, it's a really high fertility site. We saw a decrease in the second year. A lot of our other studies might not be till the 3rd or 4th year, but here we started to see a reduction in the second year. But we also noticed that that reduction was buffered to some extent by the defoliation events, especially in the narrower rows. So in the narrow rows, we saw a yield decline almost down to about 300 kilograms per hectare in the control, but that higher intensity system, spring and fall defoliation, that reduction was lower. Again, we want to find out now, does that same trend hold through time? And it appears not. So that defoliation really was only effective at buffering the yield decline right after it was initiated, and it appears to not have played out in later years as the stand aged. And by 2018, across the board, we had pretty low grain yields. And by this time, there's no effect of the defoliation event on grain yield, and very little differences even in row spacing. So as you can also see that there is some differences in row spacing here across the years, especially in 2017. We're starting to see higher grain yields in the wider row spacings. Now we're going to be looking at the forage yields. So we're going to start by looking at spring forage yields. How much forage is out there? Another major component to this is forage quality. I'm not going to present to you the specifics of forage quality today, but rather we're going to incorporate that into the economic assessment. So later I'll show you the economic value of the spring forage, and that's really a function of yield and quality. So here we're just going to start with forage yield. What we observed right off the bat the first year is that there was more higher forage yield in the narrower row spacings. That makes sense. There's more plants in the field per acre, especially during the first year when the wider rows haven't had time to fill in. By the second year, what we want to highlight here is that there's no difference in forage yield if when it was harvested in both the spring and fall or just the spring. So great forage yields were about 1 ton per hectare averaged across the row spacings here, and pretty similar in 2016. So 1 ton per hectare, metric ton per hectare isn't a whole lot of forage. We'll talk about whether or not it ends up being economically valued, wise to harvest that. But right now, what we can see is that including a fall harvest in that system does not reduce spring forage yields. In 2017, we saw an increase in forage yields. And I would say that that increase is more of a function of timing of clipping. It's kind of a difficult window to hit. We want to make sure when you do the clipping, when you do the defoliation event, you're not doing it too late so that you clip off the seed head, the emerging seed head, first node. But you also want to don't do it too early so that you have forage there to harvest. So I think that we just got better at optimizing the timing of the clipping, which increased spring yields a little bit. But you can also see in 2017, we started to see this yield reduction in the plots that were harvested 2 times a year compared to those that were just harvested in the spring. So this is evidence that additional harvest in a given year is starting to stress the system to some extent. And the same goes for 2018. Now we're going to take a look at the fall forage yields. So similar context, we have plots that were only harvested in the fall, and then we have those that were harvested in both the spring and the fall. So in 2017, in that narrow row spacing, it seems like there may have been a stimulation of fall biomass after the spring harvest in that narrow row. This didn't really play out in the wider rows. We observed still more biomass in the 15 centimeter row spacing compared to the wider rows by 2016. No differences in fall forage yield across the different harvest treatments. And likewise, by 2017 here, now we saw a substantial decline in the fall forage yield. We didn't have data from 2018. The project ended here, but in 2017, by the end of that season, it was evidence that there was some stress going on in the system, which makes sense with all of the biomass removal occurring annually. Now, there's also straw yields. So I'm going to refer to straw, the material that's harvested immediately after grain harvest, as straw. So this is typically considered a pretty low quality forage. If it's even used as forage, it's often used in bedding for other small grains. The straw of other small grains is often used as bedding. This is a little intermediate wheatgrass straw, is a little bit higher quality, as we'll see. But there's a lot of material out there. You can see here now we're looking at an order of magnitude more material in the summer compared to the spring forage. And we're looking at the straw yields across all of our harvest treatments and then row spacings. So the first year, almost 10 tons per hectare. Slightly more straw in the narrow row spacings in 2015. We're seeing a slight increase in straw in the second year in 2016 with the defoliation events. It's something that's interesting, especially in the narrower rows. And then here we actually sort of see a flip in the row spacing effect. We're seeing higher straw yields in the wider rows compared to the narrower rows. And again, no data in 2018 as we got to the end of the experiment. And you'll see that straw does become an important part of the economic picture here. So let's talk about those economics. What we're presenting here is potential revenue from just harvesting and selling the grain. So we have, this is grain yields times the value of the grain, and all of the economic details, which are really well thought out with an economist on the team, are in the papers. I'm not going to go over those details. But this is a potential revenue in dollars per hectare across the different harvest treatments and with different row spacings. So if a grower is just going to sell the grain, these are the potential revenues in the first year just based on grain. So definitely profitable, right? Make money selling just the grain, whether or not you're removing that forage or not. So these bars are really representing the effects of the forage and the cost of that forage removal on grain yields, essentially. By the second year, we're starting to see a decline in the revenue potential. And in this case, it looks like even the input costs of defoliation, even without using that forage, is still keeping this system profitable as a net gain. By the third year, we're starting to see some challenges here in this being a profitable system. And by the fourth, if you're just going to rely on grain, growers, in this case, probably losing money. So here are those same values, but including the value of the straw. And the value of the straw is based on hay market prices. And again, it includes the relative feed value of the material. So straw is pretty low quality, but there's a lot there. And at the time of this analysis, it was still rather valuable. And you can see that if you can sell the straw, have a market for the straw, this intermediate wheatgrass stays rather profitable, potentially for the full year duration of the stand. Now let's throw in the hay or the forage. Forage increased profitability sometimes. So right here we have this, the dark ones are just grain only, no forage cut. I should say grain and straw, but no forage cut. This is fall only, spring and fall. So in the first year in these narrow row spacings, fall only was rather similar to the no forage cut, where you almost had to take the spring forage to increase profitability, increase compared to the none. Later on in the stands, especially the second year, really saw a benefit, an economic benefit of taking those spring and fall cuttings. And then by the third year, it's kind of hit or miss. It doesn't look like the hay added, the spring or the fall forage added a lot of economic value to the system. So in summary, straw harvest was more profitable than spring or fall haying. Fall haying does increase profitability sometimes, and profitability was generally highest in the 15 or 30 centimeter rows when the hay and the straw was incorporated into the economics. Okay, now I'm going to shift gears and talk about the grazing project. And if we were in person, I hope there'd be some chuckles here, because these are two very intense looking pictures of two very generally happy, smiley people. But both of these folks were also essential to this grazing project. So this project was led by Dr. Valentin Picasso at Madison, is funded by SARE, and Mitch Hunter again executed a lot of the experiment in the later years. And again, I'm going to show you data mostly generated by him. So there's two experiments. The first is a mob grazing experiment, which has really the same treatments as the experiment that I just presented to you, but only grazing instead of mowing into mowing. So we have spring graze, fall graze, spring and fall, or a no graze control. And then we also have split plot treatments. Everything was either with intermediate wheatgrass monocultures or intermediate wheatgrass with an alfalfa intercrop. Grazing started in the spring of 2017. And then the last grazing was a spring in 2019. And then we have grain yields in 2019 as well. So the first thing I'm going to show you is the effects of grazing on forage availability. So I apologize, but these aren't ordered in the most logical way here. So we have spring forage on the right-hand side, which chronologically wouldn't make sense. But so spring forage yield, and we're looking at kilograms of forage per hectare, was right around that 500, so half a metric ton. And this study was conducted, I should also state, in Morris, Minnesota. It's a pretty tough environment. It's right on the border of the Dakotas and Minnesota, so far west Minnesota, north central area, a wide open landscape, often very windy, and can be some pretty harsh winters. But so we have general reduced, you're going to see reduced yields of both forage and grain at this location compared to St. Paul, which is extremely fertile and rather pretty usually high yielding environment. So spring forage is relatively known. No effect of the spring grazing on, let's see here. No effect of the spring grazing on the spring forage. Fall forage, again, yeah, so we have to show you the legend here. So this is the no grazing. So this would be the amount of biomass that's harvested as straw without any grazing. This is the straw biomass with a fall grazing, which there was no fall grazing at that time in the first year. So here's the straw with the spring grazing. So we saw a reduction in straw with the spring grazing. We did see a slight reduction of fall forage with the spring grazing as well. So what this is suggesting is that grazing is a little bit more intense on the system compared to a mechanical forage, where actually are seeing some slight decreases in productivity in general, and I'll show you more with grain yields. 2018, that pattern becomes pretty prevalent. So straw yields are declining with grazing intensity. Fall forage yields are declining a little bit. There's a small difference in the spring forage that, in stands that were previously grazed versus those that were not. But this really came out in the straw yields. And by 2019, first of all, overall forage yields were increased, and that is because there was some fertility limitation in 2018, and we amended the fields organically with nitrogen and phosphorus. So we were able to get a rebound in yields, but the pattern still was the same as higher intensity grazing. We saw a reduction in the straw yields, not too much in the spring forage yields. Now let's look at grain yield. So the effect of the grazing on the grain yield. The gray bars again are the control, and this is a spring graze. Nope, we have the split plot now, the intermediate wheatgrass monoculture and the intermediate wheatgrass plus alfalfa. So grain yields without any grazing are pretty low that first year, 400 metric ton or kilograms per hectare. And that was, I think, a function of this location. Fall grazing didn't have any effect because it didn't occur yet. That's why in the first year, so these are statistically similar. Spring grazing did have a slight reduction, slightly did reduce grain yields in that first year compared to those that were ungrazed. The second year, not much of a difference, but really low grain yields, and that was our indication that there's probably something going on with this field. And that's when we fertilized. We also did have a very wet, cold spring in 2018. So grain yields rebounded in 2019, which is something we haven't seen too often. And it's also an indication that perhaps we just need to be careful in thinking about, are these declines in grain yield with stand age always just stand age, or could there be some year effects going on here, and thinking about teasing those apart in the future. So we saw an increase in grain yields after adding some manure to the field. Generally here we're seeing an increase in grain yields with the monocultures compared to the alfalfa bicultures. And we are seeing some effects, detrimental effects of the grazing on grain yields. Now I'll present results from the last experiment. I know I'm running out of time here. This is just a fall-only strip grazing experiment. So the idea here is that you have these different paddocks. Let's just assume that right here there's 12 paddocks. Each paddock is grazed for just a couple of days at a really high stocking rate. It's a mob graze within each paddock through time. So every couple days you just move the cattle from paddock to paddock till you get through all 12, which is a little bit more than a month of grazing. So we'd expect here that during this time, forage quality or forage yield would increase and quality would decrease. And what we wanted to do is identify, is there a sweet spot in time here? Can we figure out where yields and quality are optimized? What I'm showing you here is forage availability. We did this with an intermediate wheatgrass and alfalfa biculture and a pasture, conventional pasture of grasses and legumes. 2 years of data. I'm going to show you this same data in a little bit different format here. We actually observed is a slight decrease in forage, total available forage through time, which isn't exactly what we expected, but that could be just an indication of maybe some senescence already going on. One important finding, something that's interesting here, is that the cattle performed similarly on the intermediate wheatgrass alfalfa biculture compared to the pasture. So this is average daily gains in both of those systems in the 2 years during the strip grazing. So that's a positive outcome. Grain yields, in the first year, we did see a slight decline in grain yields with the delayed grazing. So as those paddocks that were grazed later on in the fall had slightly lower yields than those that were grazed earlier, but that wasn't prevalent in the second year. There's a little bit more noise in the data in the second year, but it seems like that played out in year 2. So what's next with all of this work? The SARE grant is over. We have all of our data. The last bit of data was collected in the grain harvest in 2019. So we're working on analyzing that, writing it up. Dr. Nicole Touches is coming back on board and is going to be working on those papers. And then we have lots of on-farm grazing data to be analyzed. And if someone's interested in participating in that, I think that there's some opportunities there. maybe Valentine would be interested in talking to you more about that as well. And then the next step too is really taking a look at the soil health impacts of grazing. Putting all this into the context of regenerative agriculture. How do these animals affect the soil health of the dual use Kernza system? And I just want to acknowledge all the people who are part of this research in general, and of course, the funders. And with that, I think we can open it up for questions.
Hey, Jake, thank you for the excellent talk. We are out of time for questions, but I think we can have you answer them. If you open the Q&A box at the bottom, Jake, you can write answers to them, and I think everyone will be able to see those if they go to their own Q&A box. So we'll take the questions there by text if that's possible.
Sounds great.
All right, thanks.
Yes, we can do that. And we're going to kind of shift things a little bit now and move into more of the food science and some of the malting that has been done. And some of that work will be addressed in later days as well. So at this point, I'd like to introduce Christopher Abbott and Nick Gardner. Christopher is a co-founder of Sprowt Labs, and Nick Gardner is Sprowt's first employee. Sprowt is a hardware technology company that manufactures small-scale malting equipment and other grain processing machines. They received a multi-year grant to research Kernza malting from the Minnesota Department of Agriculture, and they're going to tell us about that work. I see you guys.
Great. Thanks so much, Tessa. Great. Okay. Good morning, everyone. I'm Christopher.
And I'm Nick.
And thanks so much for joining us. So, yeah, so we started as a company as Sprowt Labs back in 2015. And as Tessa said, we're focused on developing pilot malting equipment, and that's still something that we do. But as we've continued to grow and expand, we've been sort of reimagining the trajectory of our company and are seeing it under a name of Perennial Foods. And we see ourselves as a holistic farm gate to consumer solution, working to accelerate perennial agriculture. And we see our work is based on the hardware technology that we've gotten our start in, and where really our core competencies are, and being able to drive further grain processing innovation, and then on applying that grain processing innovation and bringing products like Kernza to market. So we understand and think of our work within 3 divisions and things that we've been working on for several years. Sprowt, where we got our start. We continue to manufacture this small scale malting equipment, which is really a pilot scale. It's lab equipment for academics or hobbyists or companies that want to be able to take on malting innovation at a small scale where they can gather a lot of data and minimize risk. Perennial Pantry is our direct to consumer food arm. We just had a successful crowdfunding campaign bringing direct-to-consumer Kernza flour and grain to market. It's just wrapped up, and we're now bringing on milling capacity and expanding our cleaning capacity. We've built some of our own cleaning equipment, dehulling equipment, and we're now in the midst of building vision-based color sorting equipment to round out our capacity on that side. And then Harlan Grains is a project we've been working on for the last 4 years or so, reviving heritage varieties of small grains, and we see that as integrated under this umbrella as a way of bringing on annual transition crops that can still be a premium option for farmers and help bring farmers into our supply chain until additional perennial options are available. So we see that as being able to offer heritage beans or interesting oils before silphium and other crops are ready. And so it's a lot, and we're a small team, but we really believe in a general philosophy of being able to engage in a whole lot of components within the processing and wider supply chain, and think that the expertise that we can draw from experimenting with all of those things at small scales enables us to really reimagine what the processing infrastructure would look like for a new agricultural system.
Yeah, and so we're here to talk about Kernza malting today. And so I'll start by giving just a brief overview of what malting is. So malting is like a partial germination process of the seed. Malting is, for a brewer, is akin to milling for a baker. A baker can't make bread with wheat, for example, she needs wheat flour. And similarly, a brewer can't make beer with barley or wheat or Kernza. She'd need malt. So,
Guys, your presentation is not advancing on our screens. I'm going to try and stop the share and maybe reshare.
Okay.
yeah, thank you. Maybe the full screen.
How about now?
No, I'm still just seeing the first slide. And it's not in the presenter mode
Oh, okay.
or presentation, I guess. We're seeing the whole, the outline.
Okay.
Maybe, there we go.
That's working?
Yep.
Okay. Thanks, Tessa.
Excellent.
Yeah.
Thank you. But anyway, malting would take a seed that would, hurt your teeth and make it crunchy and sweet, and it tastes a bit like a grape nut, a malted seed. The 4 stages of malting are cleaning, steeping, germination, and kilning. Before you malt, immature seeds and chaff are cleaned out, and then as you start malting, you would steep the seeds to raise them to a 38 to a 48% moisture content, kickstarting the germination. Of course, in the germination phase, the seeds modify energy reserves and begin growing rootlets in their first stalk, and then the kilning phase pauses that germination, pauses the seeds using their available energy reserves to become a plant, and instead dries them down and lets brewers restart them. The malt industry has historically been dominated by a small number of really large companies. However, over the last few years, there's been a real explosion in growth of small craft malting companies, and that's a big part of why malting Kernza seems like something that's really exciting and likely to take hold. Next, we'll get to how brewers use malt. Essentially, brewers will mill malt and then mash it, which basically makes grain into an oatmeal. And then they'll rinse the sugars out of the grain bed. The sugar water is boiled and hops are added, and then it's fermented with yeast. A craft brewery, for example, would use all malt to create their beers, but larger breweries might use a smaller percentage of malt with a higher enzymatic potential, and then use corn or rice to fill out the rest of their grain bill. And now we might as well get into malting Kernza. Why we're excited about malting Kernza and excited about looking into this is it boils down to increasing the acreage and highlighting the taste of grain. If Kernza is not malted, only so much can be added to the grain bill. As a high percentage of the grain bill, like I just mentioned, has to have some enzymatic capacity and the proper starch available. But with malted Kernza, we could get to a higher percentage, maybe 50%, maybe higher. And then also with that percent of the grain bill being Kernza, we could really highlight and taste and experiment with the various flavors and really interesting flavors that Kernza would bring.
Yeah, and just a big part of that's really utility, making it useful for brewers. And right now it's really exciting that it's being used in beers across the country. And there's some flavor opportunity there. Certainly there's a lot of story to be told, but from just a roll call within a brewer's brew house of something that's useful for them, malted Kernza theoretically would help them out a lot more in extracting that sugar. So this is the equipment that we've developed and that we manufacture. It makes 12 to 38 pounds finished malt, which then matches up to a 5-gallon to half-barrel brewery size. And for us, what we're focused on and excited about using for this grant is, one, the ability to collect a lot of data within the malting process and really try to grasp and understand how to optimize malting for Kernza, and then the ability to automate the process and run a lot of batches simultaneously to really be able to dig into this research and trial many different recipes at once. So basically, it's just a high level of what you're looking at. There's a component box on the left that has a variety of different climate control components inside of it: a water chiller, a refrigerator, a humidifier, dehumidifier, heating system, blower, and then there are water lines and an air line that hook up to this conical, and the grain is inside that conical throughout the malting process. And then we're exchanging conditioned air and water with that conical in order to maintain the ideal malting conditions throughout the week-long process. So an operator's checking on it once or twice a day, but for the most part, the machine is babysitting the process, and then it's connected over Wi-Fi to our web application, and it's offloading information and data throughout that process to be able to remotely monitor it, and then afterwards do some research and analyze what's happening with it. So we got introduced to the Land Institute and Forever Green last spring after previous work with the barley breeding program at the U of M, and had known about Kernza for a long time, but we're really excited to actually start working with you all on it. So we received some samples from the Land Institute and started doing just some really small batch initial tests just to get a grasp of, is this even possible? Is this worth exploring more? And we had optimistic results. We were seeing germination, we were seeing growth. Obviously, it's a plant, it's going to grow, but we were more interested in the reality that it was coming off with interesting flavors after it had been kilned down. And then we were doing some basic hot steep analysis, which we'll talk a little bit about later, but is basically a very rapid way of being able to get to a similar result as beer without the entire brewing and fermentation process. And from that, with some Brix readings, we were feeling optimistic about being able to extract some sugars out of it. The challenge that we were seeing was poor germination. 89% germination, that's decent, but really in malting, you need to have a very high, ideally 99% plus germination rate, which we'll also get into later. But this is sort of an initial look into it, and we felt like, okay, this is interesting, there's possibility here, and we'd like to be able to move forward and research this more holistically and really figure out if this would be a viable thing for craft malt houses to be able to scale and bring to market. So we applied in the fall, and then in the winter received a crop research grant from the Minnesota Department of Ag. It's titled Assessing Characteristics, Quality, and Flavor of Kernza Malt. So this is 2 years of research and then 1 year of outreach to be able to really fully examine this and figure out if we can move on it.
Yeah, so I'll speak for a minute about the grant and what our next few years of Kernza Malt research will look like. And so these are the objectives of our grant, and we've gone over this before of why we're even interested in Kernza, but really this is just trying to make Kernza as accessible and desirable to the widest range of people, and that includes brewers, and so that's that. Let's see. And so let's see, we'll begin the research by sorting and using small scale germination tests to determine which sorting methodologies will work to achieve the highest germination rate and germination capacity. And then second, we'll get into the biggest chunk of our research, and that's going to be the actual malting trials. Each trial will consist of 3 side-by-side tests every 2 weeks, and then every 6 weeks we'll pause. We'll send in the 9 samples from the last 6 weeks for malt analysis, and then we'll use that information that we learn in one round of testing to inform the next. For example, in the first round of testing, we're interested in tweaking variables during the steep phase of malting. And so we've used our own knowledge to develop a control. And from there, we'll test one steep with warmer water, one steep with control, one steep with colder, and so on. And, you know, the variables that can affect the end result of include temperature and duration of every step, as well as airflow, dissolved oxygen, CO2, moisture, and humidity throughout. And so there's no shortage of variables for us to test here. At the end of the trials, we'll debut our biggest successes with Michael Agnew, the owner of A Perfect Pint and Minnesota's first beer sommelier. And with him, we'll display our favorite malts and a tasting panel with local brewers and beer experts. And of course, from there, spread our findings throughout the brewing community. We don't intend to be academically publishing our report since we're a business, but we'll certainly distribute the findings to those interested farmers, interested brewers, and hopefully to wider communities so that more people can get their hands on Kernza malt. And then this is a bit interesting. This is the sort of thing that a panel who's tasting our malt teas will use to describe the flavor and categorize, determine what is most interesting about Kernza malt. Flavor historically hasn't been studied in malt and malting, but a couple of years ago, the Craft Maltsters Guild built and developed a hot steep method, like Christopher had mentioned earlier, of just a quick way to make a beer equivalent liquid without needing to do the brewing. And then the flavor is used on this flavor map to describe, or the flavor map is used to describe the flavor.
So we got this grant in February and we're excited to jump in, and obviously the world's changed significantly. So we hope to be in I think our second or third week of malting trials right now, but instead have been kept out of the lab a fair bit until just recently. So we've been focused on two things. One, equipment. We've added additional code and capacity to be able to take on the CO2, DO, humidity, additional readings, to be able to really flesh out the data that we'll be collecting during the malting process. And then we have been able to get in and build cleaning equipment and processing capacity to be able to really start streamlining the malting trials. So the first thing that have been digging into is germination rates. And at a high level, I mean, the challenge here is that, or what we're seeing initially, is that kernels that have either been free threshed or kernels that have been dehulled have significantly reduced germination rates. And the issue of a non-germinating kernel within malting is that it then becomes, well, one, it's not converting, it doesn't have utility to the brewer, and then two, it's a site of potential mold growth or other infection of the batch. So we've made density cleaning equipment, which is sort of our main tool, and then have modified some cleaning equipment and are making vision-based cleaning equipment to bring it all together. And our goal right now is to really refine what we've started figuring out, and certainly have been hugely bolstered by folks at AURI, who I think are talking later this week, of how to really effectively separate out just the hull on and just the hull on with the best germination rates. Early on tests are saying, we're approaching that 99% germination with just hull on high density kernels. And the free thresh certainly perform better than the dehulled grain. But that's sort of the first area we're headed towards. We're going to have our first round of malting be looking at this and comparing malted grains that are mixed, cleaned but have hull on and hull off, dehulled, free threshed, and then just hull on, and see if we're seeing different malt analysis coming off of those, and different malt quality. The other angle and why we're interested in this is that the hull could have utility to brewers as well. When brewers do the mashing process where they've milled the malt and then are sort of making this oatmeal to extract the sugar water out of, if you don't have a hull like barley does, then you can have a stuck mash, which is basically you get a big gooey mess and you aren't really able to efficiently extract sugar water out of the bottom of that. That grain mass and water mixture is usually sitting on top of a false bottom. And so when brewers are already working with grains like wheat that don't have hulls on, either they can't go above a certain percent of the grain bill, or they need sort of specialty brewing equipment that can offer additional filtration capacity, or you add in hulls. You a lot of gluten-free brewers will add in rice hulls to be able to have a mixture and have enough porous space in that bed of grain to extract sugar water. So it might offer a lot of utility to brewers to be able to have a full hull on Kernza malt and allow them to have higher percents. So we're also really excited that Professor George Annor at the U of M, who's I think speaking right after us, received a grant at the same time, which will also be used to study Kernza malting, and we're really excited to be able to collaborate with him and move this all forward together. I think George is going to be able to take it into brewing. We will not be brewing. We're going to be, as Nick was describing, making all this malt, figuring out recipes, describing that flavor. But George has more capacity in his lab to be able to make a lot of beers and take it all the way to an end product. And then also it's been great to work with Riley Gordon at AURI, who has done some initial Kernza malting and sending samples out to the Montana State Malting Barley Lab, and has done a great job figuring out how to really have an efficient processing flow. So right now where we're standing is, we're excited to dig into the actual research significantly more now that we're back in our space. And we see Kernza malt as a really viable expansion and opportunity within the supply chain. Clearly a lot of a lot of existing Kernza is going into the brewing world, and that number could theoretically increase if Kernza was able to be used at a higher grain bill and had more utility to brewers. We see, from a business perspective, a big opportunity if brewers could start making perennial percent kind of beers. There are folks at Bang Brewing who I think are pursuing that idea of, having a small percentage of Kernza malt or Kernza grain in all of their beers. Simultaneously, malting is tricky. As we launch our direct-to-consumer Kernza flour business, milling from a processing perspective still has challenges, but time-wise, you run some grains through a mill and you have flour. And malting, it's a whole week-long process and requires significantly more equipment and infrastructure. And that's going to take time to both figure out those recipes and best practices and figure out how equipment is modified to be able to best handle the size of Kernza. And then finally, if we continue down this trajectory of focusing on hull-on kernels, that means basically just an even higher dockage rate plus additional processing time. And so Kernza's, malting Kernza might run into a big challenge around price and figuring out ways to make it a viable option economically for brewers and for maltsters. So I think that's all we have for you. So thanks so much for tuning in. We're happy to answer any questions.
Hey guys, great. Thank you for your presentation. That was wonderful. We do have a few questions coming in on the Q&A button at the bottom. The first question is from Michael Palmgren. Should the starch still come from rice and corn? I think what he's getting at there is, would you mix rice corn with a Kernza malt to make a beer?
Potentially. So corn and rice used in adjunct brewing is really more how Budweiser makes beers, and not many craft brewers pursue that. So I think that just the current scale of the supply chain, I imagine Kernza are really going into craft breweries, and so I think it's much more likely that they're going to be using a majority of barley malt and then some percentage of Kernza malt.
The second question I see here comes from Sandra, and I kind of have a question that goes along with it. She's asking why the in-hull is better, and I assume that is just because it's not damaging the germ through the dehulling or threshing process.
Yeah.
As a breeder, I guess, you know, I've been breeding really strongly for free threshing ability, and for your purposes, that's going the wrong direction, perhaps. And so, should we be breeding that way, or do you think maybe you were talking about sort of a higher dockage rate, but maybe the best thing is to separate the in-hull and dehull and use the in-hull portion for malting and then the rest for milling, so that you could basically have two streams. If we're at 10% in-hull, we just take that for malting and into the future. What do you think?
Yeah, exactly. That's the path that we see. And I'm not sure. I think that it could make a lot of sense to continue down the path, or the grain that you're developing could be still very useful, just because there's a lot of wheat malt used in the world, and wheat's free threshing. And so I think that it's probably just being able to clean out to a high enough germination percent within that it works.
There's something we've never really looked at is the shape of the seed, but I've occasionally thought about trying to breed for this. If you look at the seeds, the Kernza kernel, the germ kind of hangs way off the end. It's a really small point, really easy to break off. If you look at a wheat seed, that germ is sort of moved up the side of the seed and more like a little brown shield on the side of the seed, and the radical, the root, is not hanging off the end where it gets broken off very easily. So I think you could perhaps breed for a shape of a kernel that was less damaged. It'd be good for germination and also for planting as we develop this naked seed. So, you know, naturally the seed is in the hull, and that protects that grain in the wild, but now we're making it come out of it, and then we run through machines that bang it all up. So it's not surprising that we're breaking the germs off the bottom of these seeds.
Yeah, that's fascinating. That could be a great idea. And I think one other angle that we're interested in exploring within the malting research is just the turning process. Most malt houses have auger systems that run through the grain bed in order to break up the rootlet mass during the germination process and let heat and CO2 out. And with our equipment, we're able to run batches where we don't turn or we do turn. And we're interested to see if that's going to also, you know, are those radicals going to be broken off on day 4 of germination and cause problems.
All right, great. Thank you for that. Really appreciate your talk.
Yeah, thanks so much.
We'll bring up Tessa to introduce our next speaker. Thanks, guys.
Hi, everyone. Thanks so much. I would like to next introduce Christophe David, who is from ISARA. He's a senior scientist and the deputy director at ISARA in the Faculty of Agriculture and Food Science in Lyon, France. He's been actively involved in research and development of organic agriculture in France for more than 25 years and has a personal and professional commitment to agroecology and sustainable food systems. He's currently coordinating a large program with researchers, farmers, and end users to introduce perennial grains in Western EU agriculture. And he'll be presenting with Christophe Bellet, who is an agri-food engineer and the founder of Brasserie Dulion. He is a food innovator and has developed a method for using local grains without having to develop a supply chain that includes the malting process. So he uses raw grain to produce a fermented cereal drink, much like beer, and has produced a limited run of this drink using Kernza. And I am going to share a video with you all that they prepared for today. So.
Welcome to our place. We have 4 objectives in this project. The first one is to have a better understanding of Kernza and more generally on perennial grains by comparing different materials from domestication and hybridization. The second one is to evaluate the performance of Kernza in different conditions with farmers. The third objective is to introduce perennial grain inside cropping system by working with farmers on new prototypes to introduce these new crops. And finally, we have an interest to evaluate the economic value of the perennial grain by testing different production. We are producing beer with Brasserie Dulion, and we are also testing some bread. At ISARA, we are running applied research, and we need to work closely with farmers and end users.
Hi everyone, my name is Christophe Bellet, owner of Brasserie Dulion. Graduated from ISARA in 2010 and working on this specific process that led us to brew some beers with Kernza. The Brasserie Dulion concept is quite unique. We developed some fermented beverage like beer, but without using malt, only unmalted grain. Main objective of doing like this is to be able to source the cereals locally and to reduce our impact in terms of energy and water consumption. Second aspect of the process is that we can also work on any types of cereals. The idea came because when we actually were looking at the market, we just see that it's not like in the wine production. Making beer is really complicated to make it with local ingredients. We saw that the problem is that you have between the farmer and the brewer another industry called the malt industry. And so it's really complex for brewers to actually source local grain. So the idea was to skip this step in order to brew a really local beer, terroir-driven beer, actually. So this is the core range of products we actually produce at the brewery. Here is, for example, a lager called Avant-Garde. Specificity of this beer is that we can actually we make it in 8 different versions. So we have some agricultural contracts with farmers based on the region we have around Lyon. We can actually produce a really specific beer where we actually sell it. So for example, this one is called Ultra Local 69. It means that the cereals are coming from Lyon and we distribute this beer in Lyon. The ultra local concept is something that is really interesting by bypassing the malt and being able to source cereal directly to the farmers. The second interest of working with a malted grain is that we have the possibility to really use the grain we're putting in the recipe. Just as an example, a wheat beer normally got something like 10-20% of unmalted wheat in the recipe, and it's always a base of malted barley. So you bring the flavors of the wheat, but not as far as we can go with our process. We can really bring the flavor of the cereal, and that's what we made also with the Kernza. The idea was to make a just simple beer without any specific hops or yeast around the cereal, but the idea was really to bring the flavor of the Kernza. Innovation in the brewery comes from the process, but also from the machinery. Working as we are doing is a bit specific. It's not exactly the same types of machinery we're using in a traditional brewery. The idea was to also develop a process that is less energy and water consuming. So we also developed some specific brew house system, for example, for filtration, and also we are working on a specific full electric concept of production. The next step for Brasserie Dulion is to be also self-powered with renewables for production, and not just the valves and the pumps, but also the heating of the whole brew house.
The good part of my job is to work to support sustainability. And I really believe that Kernza could be one option to introduce more sustainability within European agriculture.
Good part of the job is to test the quality of the product. Santé!
Okay, and so we have lots of time for questions and answers, and Christophe are both on. So if you all have questions, please go to the Q&A section.
Okay. Could you hear us? Okay.
You may have to stop the audio on one of the accounts that I think you have open.
Yeah, I think it's, is it okay now?
Yep.
Okay.
Yep.
So the first question is about the fertilization process.
Regarde le Q&A.
No?
C'était un truc qui a été résolu.
Ah, okay.
Ah, okay.
Ah,
Could you go more regarding
So-
that, regarding flavor?
okay. It's a bit subjective, but we can say that it has a specific flavor. Maybe a derivated from the wheat, as Kernza is a kind of wheat, and yeah, it's quite complicated to explain a flavor for me, but because we are using only Kernza, we got the taste of Kernza.
We decided to make some sensory tests in the near future with from this beer, and from the first feedback we received, they say that the flavor is it seems green, like the cereals, pure cereals, but the quality and they say that it's you could easily discover the type and the flavor of the grain, and it's better than with malting process.
In terms of maybe more technical aspects of the brewing characteristics, the color also of the beer, kind of it's not really pale beer, and we didn't use any roasted Kernza, only pure Kernza without any roasting, but the color of the beer is really interesting because we get a kind of red color almost. It goes also with the flavor, but yeah, in terms of process, because we know how to process all kinds of cereals with Brasserie Dulion, but Kernza was really promising in terms of taste and also in terms of process, because the grain are really small, but not really complex for us to brew compared to barley, for example, pure unmalted barley.
So the next question is, what's the amount of Kernza that you use to produce the beer? So how much does it take?
450 kilograms.
The yield in the process was quite similar to a regular wheat, so around 400 kilos to make 20 hectoliter of final product at 5% alcohol.
And dual grain, yeah.
Okay. And the next question is this beverage currently for sale? And what sort of venues do you sell it at?
No, it's just a research project, because inside the cooperation with Land Institute, we decided to start a research program without any business issue. But for us, it's important to run research and to evaluate the potential interest for farmers and users. So that's why we decided to work with Christophe, just to try to work with this new beer, and just to evaluate the potential of this beer. It's as Christophe mentioned before, that the business is open, and when we could receive the agreement from EU, because it should be recognized at the EU level, we could probably open the market. Actually, currently the Patagonia provision is working on the European market, but Christophe is, yeah, you could say a
No,
little bit more.
just we're not selling the beer, but of course it's really a product that I have few stock here, and when my clients are coming and also the farmers we're working with, it's always a good chat we have together, so I can show we taste the beer together, and explaining also what the potential benefits regarding the agricultural production that this Kernza can bring also to the farmers and things like this. And many of my, let's say, clients and partners, like agricultural partners, are really interested in the product and in the Kernza. And finally, yeah, I was really enthusiastic when Christophe asked me to do some trials with the Kernza, because with our unique process, we are always looking at really, we're making beer with rice, with millet, sorghum, fonio, whatever. And Kernza was like really a new challenge. And every time, the idea for us is to bring a new product, but also to see the potential and the potential of the fuse. And with the Kernza, we see that the stability of the beer is really good. Yeah, we decided not to make a crafted style Kernza beer. The idea is like we made a simple beer. Normally, when you're making a lager beer, like simple beer, the idea was just to see maybe the potential of flavors coming from the production, the stability at long term of the product, and the real flavor of the Kernza. Of course, we could have made a double IPA with, I don't know, lots of hops, yeast impact and things like this, but this was not the idea. The idea was really to make a simple beer, but to see the real potential of the grain and not to put many flavors around. So that was the main idea with the project.
So the next question is, in your experiences so far, do growing conditions and other environmental factors that impact the grain, protein, and sugar profile impact the flavor and malting quality of beer made with Kernza? So can you tell, and this is sort of my follow-up on that, is can you tell like a field to field effect? Like
it was hard to we just started that this part of the project concerning the processing. For this experiences, we just took some batch from a field without any fertilization. And I could guarantee that for sure, with nitrogen management, we're currently working with partners in Belgium, Jean Bleu, and they're testing different nitrogen fertilization, and like Jake and other partners in US. I'm pretty sure that we could increase probably the protein level, and we could change the profile of the protein. For this type of beer, we had more than 16 the protein rate, but without any improvement. So it's just the beginning of the project. For sure, we could change the value, we could change the quality of the grain, and we could change the flavor. But it was not the objective of this project.
Also because we worked with a mix of grain from different fields.
Yeah.
So at the moment we tried the Kernza, but not Kernza associated with a soil or terroir.
Yeah.
But of course we see it for example, barley. The story behind the way we produce the malt with the barley, it narrows also the strains in terms of barley, so it narrows also the potential of different varieties in terms of flavor. We made some trials. It's not directly, but I think it can be the same with Kernza. with ancient varieties with strange size of grain, things like this, regarding barley, and we see that we can bring specific flavors. So we are pretty sure that this is something we really see in the wine production, but because we use the malt for producing the beer, I think we are missing this part of the flavors because we need to malt the grain. So I'm pretty sure that Kernza is also terroir driven when it's grown.
So can you describe, this is the next question from Colin Curitan, can you describe some of the market trends that you're seeing in France and the EU regarding local and sustainable beer? And is there a strong market demand for the ultra local products and perhaps a 100% Kernza beer as well?
Okay, probably first it's to consider that agroecology and producing in different ways is very attractive now in Europe and especially in France. So we have this, the interest for us is to work with Kernza with a situation with low input. We don't want to copy the conventional agriculture, and we don't want to provide more and more nitrogen. So this is the first point. The objective is to test Kernza in situation with low input. We don't want to use chemical product. We are ready to use some fertilizer, nitrogen, PK, but in the very minimum level. For local and sustainable beer, local business is quite
part of the market is absolutely looking for. So we are really in the trend of local and organic products. So what is really interesting in the way we are working for the end consumer is that they can understand where the ingredients are coming from. So of course this is something that is really powerful also in terms of market. But with Brasserie Dulion, the idea is to really look a bit further in the way we produce. The idea is really to bring back also the farmers, because at the moment, most of them producing some cereals, they produce same rotation, the soils, we see that there is a impoverishment of the soils. They don't know really where the end product, how their cereal are used and things like this. And the way we produce this beer is, of course, to answer a kind of market needs from the final customer to be able to say, okay, we're doing our product is cereals coming from here, everything is made organically and things like this. But the really the real idea behind what we're doing is that we and Kernza is part of this concept, is that we want to really bring back the farmers into the production, so we can directly work with their cereal. So by passing the malt gave us the possibility to also make, for example, additional cost of we bought the grain not like super low, but we actually buy the grain almost the same price as the malt. So the idea is that really the farmer see a real interest of working with us, and the idea is not to go like making a cheap product. The idea is to be attractive in terms of because there is some economic reason of working like this, but the idea is that we can share the values also to the source of what we're doing, so the farmers. And working with untraditional cereals like Kernza, it's the possibility to maybe also add the added value to the farmer by, for example, giving them the possibility to grow also intercultural crops, so sorghum, millet. Kernza also brings them the possibility to regenerate the soils of specific fields, change the rotation. And so the idea is that we can deal with as many cereals and plants we can, so we can really adapt to the farmer and not the farmer adapt to us. That's the way we see the way we produce the beer.
Great. The next question is from Valentin, and he says, is the beer only available in Lyon or other places in France and Europe? And when are you shipping to the US?
I think that it's available at home first. So you need to visit our place. That's why we just, start with this small video. I think it's, we have more than, I think, about, I have many bottles at home, but outside here and at home, we have no market now. Just one opportunity. When I visited Patagonia Provision in January, we tested Agronomy because it's also made by our partners and with Olivier, the PhD students, with Patagonia. There is a potential for sure for Kernza, because I consider that yesterday we talked about this dual use. Okay, we could use grain, we could use forage, but there is another use, there's services. And my belief is to produce a direct value for these services, like regenerative agriculture, and Kernza is good potential.
And just to finish about the brewery concept, the idea is to really work on a specific area. So even Brasserie Dulion, so we have a large production because the capacity of the brewery in Lyon is around 10,000 hectoliters. So it's like a mid-sized regional brewery. But we're not selling in Paris because the whole objective of the production is to really do everything from agriculture, production, and distribution. And we're not close to go to export, but the idea is to export the breweries. There is another part of my job is that we also build our, let's say, the process and the breweries. And the idea is really to duplicate the model. So if we want to produce some beer in the US, it's not a problem at all. We can provide a complete brewery, so no problem.
Great. So the next question is from Matt Baker, maybe? I don't know. For your process, do you prefer free threshing Kernza versus the problems that the previous speaker mentioned regarding reduced germination after the cleaning and free threshing seed?
I'm not using malt at all, so.
So it doesn't matter if it germinates?
Just the fresh product.
Fresh product. And it's the innovation here. It's a old story, and we would like to work with pure cereals for I can say pure product.
Did the grain you use have the hulls on or mostly naked seed? Was the hull on or naked seed that you used?
Naked.
Very naked.
Naked, but not very well done. It's very traditional now.
So the next question is from Nima Homami. Do you think that Kernza's main selling point should be its unique flavor or the story behind it with regards to the sustainability and those things?
I think it's not a question of flavor. It's a question of general global concept. And that's why we try to promote research and development to introduce more sustainability within agriculture and food sectors. It could be in organic, it could be in low input systems. We are open to work with some conventional farmers, but I believe that we are not looking for a specific flavor. We are looking for, we could find some specific flavor for sure.
The flavor is quite specific.
The flavor is specific, but the story is specific. As I mentioned before, it's the tree value, the tree use. So it's, for me, it's a question of the global concept, and within this concept, there is a question of the flavor.
So the next question is, can you specify the grain traits that need improvement for beer production?
What do you mean by traits?
So I wonder, something as they were talking about before with the shape of the grain, increasing germination, or
just to mention something that now we are using the cycle 3, so from Lyon, from the Land Institute, so we are not using cycle 5 or other materials from University of Minnesota. So the objective for next year will be to start new experiments with INRA, testing different materials. So I think that genotype is a question. And we have also this question of crop management. Yeah, and so the size of the grain could be very different. As you mentioned yesterday, Lee, from cycle 3 to cycle 5, there's a large difference. So probably we will obtain different beers if we process with other materials, with other crop management.
Just to answer the question, for our process, our process is quite robust. So in terms of if the grain is a bit, the crop, there is a variation in terms of size of the grain, capacity of germination, protein, all those stuff. It's not a big deal for us, but I know that for the beer, like regular beer production with malting, it's a really big problem.
So the next question is a little more technical. But how is the grain processed and then brewed? And is it possible to obtain more information on the production process? And then finally, where did the amylase enzymes come from without a malting step?
So this is part of our specific process, but of course we're using enzymes for production. And directly in the process, we actually wake up also the enzymes from the grain, but we are not going through the malting stage. So of course the enzymes are coming from external source.
Okay, and then the final question, we have just a couple minutes. So can you comment on any adjustments that you've made, that you've needed to make in order for your mashing profile? So temperatures, enzymes used, conversion times for your brews made with unmalted Kernza versus brews made with unmalted wheat.
You need the full receipt. No, of course there is a lot of parameters. Yeah, this is part of the, let's say, the Brasserie Dulion process, so I'm not gonna really explain all the stuff, but of course you see in the videos we have specific machinery, filters, parameters, so it's quite, yeah, quite similar to regular brewing process, but we're working on this for like 6-7 years now, and this is part of the, let's say, the know-how of Brasserie Dulion.
I believe that probably, maybe the next Kernza meeting in not next year, but in the next years, we could organize some meetings in France that you could easily answer or find all their questions to Christophe or to our programs in general.
Perfect.
So visit us after this COVID situation. You are welcome, and we could test some beer.
Perfect. Thank you guys so much. I really appreciate you talking about this new process.
Bye.
Thank you.
Thank you. And next we're going to move into tempering and functionality. So the next presenter is Radhika Bharathi. She's a graduate student in Dr. George Annor's lab, working on establishing optimized tempering conditions for intermediate wheatgrass. She holds a bachelor's degree in chemical technology from the Institute of Chemical Technology in Mumbai, India, and started her master's in food science in the fall of 2018 at the University of Minnesota. She's passionate about sustainability. She is a passionate sustainability advocate and feels fortunate to be part of the Kernza commercialization projects. She's recently converted her master's into a PhD under Dr. Annor and will continue working on projects on the upcoming intermediate wheat grass food science projects. And I think Dr. Annor is also going to speak a little bit toward the end of her presentation. So you'll get to hear from him as well. Thanks, Radhika.
Good morning to one and all. Is my screen visible and am I clearly audible?
Yep.
Yes.
Okay. So I'm Radhika, a graduate student in food science, and I'm excited to present my research focused on establishing tempering conditions for intermediate wheatgrass and why I think tempering is the secret to better refining intermediate wheatgrass. George, my PI, and I are co-presenting today. So as a heads up, I will be presenting the first set of slides on tempering, and George will take over the last couple of slides to talk about upcoming projects on intermediate wheatgrass. So let's begin. Many consumers around the world are becoming increasingly interested in sustainably produced products, mainly due to growing awareness about the evils of large-scale industrial agriculture, which is often touted as a major contribution to soil and water pollution, causing global warming and even triggering climate change. A recent survey released by the Earth Day Network and the Yale Program on Climate Change shows that 51% of Americans are interested in eating a more climate-friendly diet and are willing to change their eating and purchasing habits if they had more information about the environmental impacts of their food choices. So although there are many ways to make food production sustainable, promoting novel perennial crops like intermediate wheatgrass is a particularly interesting option, and it aligns well with the current market trends. So intermediate wheatgrass provides a range of rewarding ecosystem services, and I'm sure we're going to hear more about that in the coming days. But as a food scientist, the most important factor about intermediate wheatgrass for me is its superior nutritional profile. Intermediate wheatgrass has higher protein, fiber, and antioxidant levels than most cereals, including wheat. However, when we consider intermediate wheatgrass as a potential ingredient for manufacturing, we need to make sure that it meets manufacturers' expectations as well as consumer demands in terms of taste, texture, shelf life, and functionality. And this is where I believe we have a problem to solve. So intermediate wheatgrass faces some functional challenges. Although it is rich in protein, it has high level of protein content, but it is deficient in a certain class of gluten-forming proteins known as high molecular weight glutenins that are critical for gluten development and impart gas-holding properties to baked products. Due to its relatively short domestication history, intermediate wheatgrass has a relatively small seed size in comparison to wheat, meaning that it has smaller amount of starchy endosperm and a high bran to endosperm ratio, making it rich in dietary fiber. So why is dietary fiber a problem? Since we have a mixed, diverse audience in the room today, I'm going to explain some basic principles here. So gluten is a polymeric network that is formed when gluten-forming proteins come in contact with water during dough making. However, certain other flour components such as fiber or damaged starch can compete with proteins for water, thus hindering the gluten network development. Therefore, we need to employ processing strategies that can lead to stronger gluten formation and improve intermediate wheatgrass functionality. Refining is an obvious choice that can improve functional properties, and progress in domestication of intermediate wheatgrass has produced grains with larger seed size that enables bran removal. But in order to use intermediate wheatgrass as a standalone food ingredient, we need to optimize the refining process. We need to better separate the bran from the endosperm and produce high quality refined flour with superior functionality. So one strategy to do so is via tempering, which is basically altering the moisture content of the kernel prior to milling. So tempering is a critical pre-treatment step that takes place before milling, and it involves adding calculated amount of water to kernels to elevate the kernel moisture and then incubating it at certain temperature and time combinations. Tempering toughens the bran and it softens the endosperm, so it kind of makes it easier to peel away the bran layer from the starchy endosperm. And why temper and why does it matter? This is because tempering conditions have been established for most cereals, including wheat. And there are research studies which prove that tempering improves milling efficiency and flour functionality. So if it works for wheat, why not for intermediate wheatgrass? In this study, we decided to explore the effects of kernel moisture, tempering time, and tempering temperature on the physiochemical properties of intermediate wheatgrass flour. Accordingly, a 3x3x2 experimental design was set up with factors as target moisture at 3 levels, tempering time at 3 levels, and tempering temperature at 2 levels respectively. So tempering experiments were carried out in 4 simple steps. The first step, step A, is altering the moisture content by adding water to kernels to achieve either 12% or 14% target moisture. Non-tempered kernels where no water was added were treated as controls. Step B, the kernels were incubated either at 30 or 45 degrees centigrade for 4, 8, or 24 hours. Step C involved milling the tempered grains to flour. And step D involves separating the flour from the bran fraction. So my research aims to optimize the tempering conditions for intermediate wheatgrass by selecting the ideal target moisture, tempering time, and tempering temperature that can yield flour with the best physiochemical and functional properties. So here is a sneak peek into my tempering experiments, and looking at this picture actually makes me nostalgic because it's been a while since I visited my lab. But anyway, in this picture, the transparent container on the left is a tempered sample, and hence the sieve on the left contains more brown bran particles and is more efficiently refined in comparison to the controlled non-tempered sample on the right, showing that tempering toughens the bran and facilitates better separation. So after tempering and milling, the refined flour samples were then analyzed for the following compositional and functional tests as listed in here. I would also like to mention that the variety of grains that we used was MN1503 that was grown and harvested in Becker, Minnesota. So moving on to the results, how did tempering improve refining? Intermediate wheatgrass bran is rich in minerals, fiber, and polyphenol oxidase. That is an enzyme responsible for darkening and discoloration in cereal products. And hence, color, ash, and polyphenol oxidase value results can often be taken as a proxy for bran contamination of the endosperm. So samples tempered to 12 or 14%, known as the tempered samples, were lighter, less brown, and more yellow in color, with reduced ash and polyphenol oxidase activity as expected in comparison to non-tempered samples. Out of the 3 factors that we're analyzing, target moisture, temperature, and time, target moisture had the greatest effect on all of the 3 parameters, color, ash, and polyphenol oxidase activity. This can be seen in the graph right here. I'm going to be showing a couple of similar graphs. So the y-axis will represent the parameter being analyzed. The pink bars represent the non-tempered samples, whereas the blue bars represent the tempered samples, with the darker one being 12% and the light blue one for 14%. And as you can see, increasing target moisture led to a lower amount of polyphenol oxidase activity. Another interesting observation was the peculiar high yellowness of intermediate wheatgrass flour, and this is due to its high carotenoid contents. And the good news is that tempered flours also have high yellowness, which means that carotenoids are not lost during processing, but we still have to measure carotenoid levels and corroborate this. So the high yellowness and low polyphenol oxidase activity of tempered intermediate wheatgrass flour make it an attractive option for noodles and cakes, where lighter flours and low polyphenol oxidase activity is desired, as high levels of this notorious enzyme can lead to discoloration or specks in products like noodles. So moving on, let's talk about proteins. Just like carotenoids, refinement did not always lead to loss of protein on a dry basis. As seen in the graph on the left, protein content of non-tempered samples in the pink are not very different from the tempered samples in blue and green. and thus protein contents were barely altered and reductions, if any, that were observed were minimal. So this is also good news because the high protein characteristic of intermediate wheatgrass is maintained over refinement process. However, in contrast to proteins, insoluble dietary fiber values were significantly lowered in tempered samples. And this was expected since dietary fiber is usually found in the bran layers and we're getting rid of the interfering bran particles via tempering. And similar to ash, color, and polyphenol oxidase activity, target moisture had the most significant effect, with samples tempered to 14% containing the lowest levels of insoluble dietary fiber. Moving on, speaking about starch, so the reductions that were seen in ash and fiber levels obtained via tempering were reflected in significantly higher starch contents. Samples tempered to 14% target moisture had higher starch contents than samples tempered to 12% or the control samples, showcasing the significant effect of target moisture on starch levels. So in the previously conducted studies, the starch content values for intermediate wheatgrass were less than 45%, and by tempering at 14% and 45 degrees centigrade, starch contents of about 65 grams per 100 grams of flour on a dry basis were achieved. I think this is a noteworthy result because this is in the range seen for whole wheat flour. So whole wheat flour typically contains 55 to 65% starch, and intermediate wheatgrass is reaching that level. However, the increase in starch content also coincided with an increase in starch damage. Now, starch damage can be explained as the rupturing of granular starch structure due to milling. Damaged starch absorbs 2 to 4 times more water than regular starch granules and are more susceptible to enzymatic degradation. So at higher levels, starch damage can negatively affect functionality due to their high water absorption and could also obstruct gluten formation. But below a certain threshold, starch damage can actually be beneficial for products like breads and can improve their quality. So moving on, how did tempering improve functionality? So by now you're aware that protein, starch, and certain other fiber molecules all compete with water during dough formation, all compete for water during dough formation and form respective polymeric networks. And solvent retention capacity is a solvation assay based on enhanced swelling behavior of individual polymeric networks present in the flour in diagnostic solvents, namely aqueous lactic acid, aqueous sodium carbonate, and concentrated sucrose solution. So this test basically evaluates how much of a certain type of solvent is entrapped by polymeric flour networks. And although all the solvents give valuable information, lactic acid solvent retention capacity is of particular importance because lactic acid swelling indicates gluten network development and can be used as a tool to predict flour functionality. And as shown in the graph here, samples tempered to 12 and 14% target moisture had significantly higher lactic acid solvent retention capacity values than non-tempered samples. So this indicates that when the extent of refinement is increased, intermediate wheatgrass flours can develop stronger protein networks, which would be beneficial for products requiring gas holding properties. So the next test that we did was glutopeak analysis using a glutopeak tester as shown in the figure. So this is a rapid instrument used to measure gluten aggregation kinetics in a short period of time using a small amount of sample. So during the test, flour sample is usually mixed with water and subjected to intense mechanical action by a rotating element, and it measures torque through stages of gluten development. The increase in torque values captured by the instrument corresponds to a proportional increase in the formation of gluten network due to increasing consistency of the slurry mixture. So after reaching a maximum value, the torque curve declines due to prolonged mixing at high speed, which causes a breakage in the gluten network. And the results indicate that samples tempered to 14% target moisture at 30 degrees centigrade exhibited higher gluten aggregation values than 12% on non-tempered samples. Once again, this shows that target moisture had the greatest effect on gluten aggregation. This may be due to the fact that tempered samples were better refined and had lower bran content in these flours and thus less interference with protein network formation. Tempering temperature also had a significant effect because samples tempered to 45 degrees centigrade showed lower aggregation energies than samples tempered at 30 degrees centigrade when keeping target moisture and time constant. So this brings me to the ultimate question we are trying to answer. Have we found the ideal condition for intermediate wheatgrass tempering? Well, the answer is partly yes and partly no. This is because we haven't found the one chosen condition yet, but playing by elimination rule, we know for sure which conditions are not favorable and which ones will be beneficial. Furthermore, we are still in the process of analyzing tempered flour samples to understand their water absorption tendencies using a farinograph, protein solubility studies, protein profiling studies, and all of that is still in progress. But so far, most of the results indicate us or point us in a certain direction. For example, we know for sure that tempering at 30 degrees centigrade is more favorable than 45 degrees centigrade. This is because at 45 degrees, we saw higher starch damage levels and lower protein aggregation. When it comes to tempering time as a factor, we observed that it had very minimal effects on various parameters analyzed, which tells us that maybe 4 hours is sufficient to get the desired results. And target moisture had the most significant effect on all the parameters analyzed, which leads us to suspect that either 4 hours, 12% at 30 degrees, or 4 hours, 14% at 30 degrees may be the best suited conditions for intermediate wheatgrass. So once the labs open up, we'll be able to get the final tests done and solve this puzzle. And my final takeaway here, so tempering significantly improved the properties of intermediate wheatgrass flour by producing refined flour that was lighter in color, had high yellowness, maintaining carotenoids over refinement. Tempered flour also had significantly less ash and fiber levels, but showed higher starch and starch damage. Tempered flour was also able to form stronger gluten networks as indicated by higher lactic acid and solvent retention capacity values due to better separation and reduced interference by bran particles. And finally, out of the 3 factors that were analyzed, we think that target moisture had the most significant effect on all the parameters, followed by tempering temperature, and tempering time almost never mattered and showed minimal effects on several parameters analyzed. So through tempering, we can produce refined Kernza flour with attractive properties and different streams of flours that will encourage industries to incorporate Kernza into product lines for breads, noodles, cakes, etc., thus significantly diversifying its product portfolio. So moving ahead, what we have planned next is to conduct baking studies using the tempered flour produced under optimized conditions. So I will be baking some delicious Kernza breads and maybe even cookies and noodles, and characterizing these products to analyze and understand the overall effect of tempering on the baking performance of intermediate wheatgrass. So that is all I had for today. I want to extend my thanks to our funding source Forever Green and all my collaborators, internal and external to UMN. And I'm going to let George take over now.
Okay, so I think I cannot share my screen. Yeah. Radhika, can you stop sharing?
Yes.
Oh, my video doesn't work there, sir. Anyway. Okay, start.
Okay.
All right. So let me share my screen here for a sec. And can you all see my screen?
Great. Yeah, we can see it and we can hear you.
Okay. So I'm George. I'm George Annor. I'm an assistant professor in food science department. I'm a serial scientist working on processing of cereal grains. And I'm particularly interested with, of course, on sustainability and also working with breeders and looking at the end use characteristic effect of all the breeding that they do. So moving on with this presentation, this is a project
George,
that yep.
We're seeing the presenter view, so we're seeing your notes and everything. Just
oh, okay. Let me.
So you may want to share just the.
Yeah. Okay. Here you go. Can you see now?
Yes, that looks perfect.
Okay. Thank you. All right. So I'll be looking at talking about the new project we just got funded, and it's basically improving the commercial viability of intermediate wheat grass through the development of value-added new ingredients and products. And it's basically we want to increase the demand for intermediate wheat grass and develop all these novel value-added products that can be used in various products. So we have 3 objectives. The first is to actually work with the breeders to actually document all the changes that happen nutritionally or chemically to the grain as they do all these breeding. And also we'll be looking at storage stability. It seems that intermediate wheat grass is very stable, but we need to actually document this so it will help the breeders to breed for certain parameters when it comes to processing. We will also be looking at sprouting or malting, and Chris already talked about that in a bit. But in addition to the sprouting or malting, we'll also be looking at popping or puffing intermediate wheat grass grains to get a product like Rice Krispies and used in a lot of breakfast cereals. And then these products will now be used to develop new recipes. So for the third objectives, we'll be working with Dulion to actually help us develop recipes with the sprouted flour or malted flour, and also the puffed grains and their flour as well. So for the first part, we'll be doing a general nutritional screening of all the varieties that will be coming, or most of the varieties that will be coming from the breeding program here in Minnesota. So we'll be working with Jake and Jim Anderson to screen these samples and document the changes that are happening as they go through the various cycles of the breeding. Now for the sprouting, and I'm happy Chris talked about this a lot, and he did mention they will be doing a lot of the actual research and publishing. That is what we will be doing. We want to really document the effect of the degree of steeping, that is the moisture content that you actually need for the seed to germinate. And we will also be looking at the temperature of steeping. We'll be also be looking at the temperature of sprouting and the sprouting time. So we'll be sprouting them at different times, taking samples and really looking at how these different parameters affect the chemical and functional characteristics. I would like to mention that for this sprouting and malting, we are not only looking at brewing, we are also looking at using these sprouted grains or their flour as functional ingredients, because we know that malting or sprouting has significant improvement on nutritional quality. The second part of it will be going to the puffing or the popping. So we'll also look at the effect of what moisture content. We'll also be looking at the time of puffing and also the puffing temperature and how it affects the grain, the puffing of the grain and the chemical composition. All these has not been documented, and we get a lot of requests from processors requiring what conditions that are necessary for puffing and what conditions are necessary for malting. So we want to document these, and these will be published and will be made available, so it will be easy to access. The third part will be the recipe development, and I said we'll be working with Dulion. She will develop products from whole intermediate wheat grass grains, the sprouted grain, the puff grain, and also their flours. She'll be using these for home cooking, so developing recipes for everyday home cooking. So this won't be for industrial purposes per se, and we think that is really very important. So she'll be looking at sourdough and yeast raisin bread, flatbreads, crackers, cookies, muffins, and snack bars. And in addition to this, we'll be doing the brewing aspect. I have in my lab a 15-gallon brewing skid. So when we do the malting, part of it will be for nutritional purposes like milling and using in other products, but part of it would also go into the brewing. So we would actually go through the whole brewing process. And again, we will use a very simple beer brewing process. The last time we did it, we adapted the recipe from Bank Brewery. They are already brewing some beer from intermediate wheat grass, and they go up to 15% of intermediate wheat grass, but unmalted. So this will allow us to also play with how much of malted intermediate wheat grass we can use for brewing. So for the sake of time, I would like to end here. And of course, a big thanks to the Forever Green Initiative. So if you have any questions, I'm ready. And Radhika and I are ready to answer.
Great, thank you so much. And we'll see if some questions come up. We have about 4 minutes. So I have a quick question, and that is whether you guys have seen any variation in this data based on like different fields or different years of harvest or things like that.
Yeah, so, well, not particularly with the tempering, because we only use from one location, but we know for sure from other studies that there's a significant difference in even the nutritional quality, the protein content, the functional properties when seeds come from different locations. And here in Minnesota, we've seen particularly that seeds that come from Crookston actually do better functionally than seeds that come from St. Paul for some reason. And I once asked Jim about this, and he thinks there's probably too much pollution in St. Paul, there's acid rain in St. Paul, but yeah, we do see changes from different locations. We haven't done that with the malting yet because we are yet to do it.
And so with those different location by location, do you think that you will do some of those studies as you have more years and more availability of different lots from harvest?
Yes, yes. And that is why in this first part, in the first objective, we want to really see, well document all those differences. So this we think would help breeders kind of go into that data and figure out what all these changes are, okay? Because even as we are increasing seed size and increasing threshing and all, we, the food scientists at the end use side, are also worried about any negative effect it might have on functionality or its use in mainstream food application.
And have you looked at like the difference between getting it directly off farm? So like just taking it straight off the farm versus having it be stored on farm? Because I'm assuming that affects the temperature and
yeah, we would think so, but it's been particularly very difficult to get grains because of all the various breeding that is going on. We sometimes even get confused as to which grain we are actually using. Luckily, of course, the clear water has been released. And so for this malting work, we are going to be using the clear water and also 2 varieties that are near being released. So at least by the time they are released, we already have some information on what they can be used for.
Great. And I'm just thinking if it would become useful, maybe we could try and get some grain also from different locations like Montana or Kansas or those kinds of places, just for comparison.
Yeah.
And we have a question from Robert Johnson. Yeah. Could you explain what starch damage is and how it affects Kernza use for products and how it's measured and analyzed?
Okay, so every grain, of course, has starch. Starch is made up of granules, very small granules. You see that a lot when you look under the microscope. So ideally, we want these granules to be whole. But the milling process is a very harsh process. And during the milling, you get part of these granules being broken apart. So when these granules are broken, we call them damaged starch. So when they are broken, they absorb water more than the unbroken one. They are more likely to be hydrolyzed by enzymes, if you have any enzymes in there. And we actually have starch damage enzymatic kits that we use to measure these. You basically add a small enzyme, you dilute alpha amylase, and you measure how much. So these alpha amylase will preferably hydrolyze the damaged starch rather than the undamaged starch. So you are able to tell how much of the damaged starch is actually hydrolyzed.
Great, thank you.
Okay.
And that brings us to 10 o'clock.
Right on time.
All right. Thank you, everyone. Thanks to all of our panelists. We're so grateful to have such great information presented. Please join us tomorrow at the same time for even some more. Thanks very much.
All right. Thank you.
Thank you.